Today my presentation will be about how to use Pascal's triangle in games. This is my inspiration. One day, my math teacher introduced Pascal's triangle in our math extension class. We were trying to discover the hidden patterns in the triangle during the whole math lesson. That brought me a great interest to keep investigating the Pascal's triangle. Pascal's triangle is one of the most interesting number patterns named after Blaise Pascal. The beauty of the triangle is that it is so simple, but also so mathematically rich. There are many secrets hidden in the triangle. This is how to build the triangle. You start with a 1 at the top. Then you add 2 more 1s below it in a triangle shape. Remember, each number is the sum of the 2 numbers directly above it. This is my investigation focus. In this math investigation, I am focusing on the most interesting patterns hidden in Pascal's triangle, which is how we can use it to find the combination numbers. I am using a few games as my examples. This is my first game, using coins. So here is the question. If you have 3 coins, what is the chance of you throwing 3 heads or 3 tails? There are 4 different combinations of throwing 3 coins. But if you think that the chance of getting 3 heads and 3 tails is 2 out of 4, then unfortunately you are tricked. There are actually 8 ways that they could land. You might think that head, head, tail and head, tail, head are the same, but looking at the possible combinations, they are different. Just imagine that they are different color or different coins, and that might help you get it. For my game, I am using 3 different coins. I used $1, 50 cents, and 20 cents. And this clearly shows that there are 8 ways. So the answer is, it is 2 out of 8 chance. Check this with Pascal's triangle. There are 3 coins, so we look at row 3 of Pascal's triangle. The first one tells you how many sets of 3 heads, which is just 3 heads. And then looking at the last one, it's how many sets of 0 heads, which is just 3 tails. So that 1 plus 1 is 2. And then 1, 3, 3, and 1 add up to 8. So we automatically know that it is 2 out of 8. This is my second game, cards. So this is the question. There are 5 cards like these ones. So what is the chance of picking 3 black cards? You might think it is easy because there are only 2 red cards. Let's calculate it by listing the combinations out. On the first round, let's say I'm really lucky and I pick 3 black cards. Then if I play this for 10 rounds, I will only be likely to get 3 black cards once. So the chance that you'll pick 3 black cards is actually 1 out of 10. Check this with Pascal's triangle. There are 5 cards, so we look at row 5 of Pascal's triangle. So the first one tells you how many sets of no head cards. So the highlighted 10 is how many different sets of 3 cards we can get. So that is what we were focusing on. This is my third game, drink combinations. So this is the question. There are 4 drinks to pick from. Let's say that they are lemonade, Sprite, Coke and Fanta. You can choose 2 fills from these bottles. You can have doubles if you want. So how many combinations do you have? Let's calculate it. So for my first combination, I might choose lemonade and Sprite. And if I list out all the combinations that I can have, I'll actually have 10 combinations. Once again, we can use Pascal's triangle to figure it out. If we look at row 4, because there are 4 drinks to choose from, and we go diagonally down, we can see the answer. So the 1 is how many you can get from 0 fills. The 4 going diagonal is how many combinations you can get from 1 fill. And then the 10 is how many you can pick from 2 fills, which is what we worked out in the table. And so if someone just asked you how many you can get from 3 fills, you can automatically say 20. This is my fourth game using 2 dice. So here is the question. There are 2 6-sided dice. So how many different combinations? There are 36 possible combinations. That is correct. But we need to pick out the repeated ones. So let's calculate it. For my game, I'm using red dice and green dice. So if we list out all the combinations, then there are only 21 different combinations. We can check how many different combinations there are, even with more dice, using Pascal's triangle. Starting from row 6, the first number is 1, and that is how many possible combinations we can get from 0 dice. And then going diagonal, the 6 is how many possible combinations we can get from 1 dice, 21 is how many different ones we can get from 2 dice. And once again, if someone asks you how many you can get from 3 dice, you can automatically say just 56. In this presentation, you have learned how to use Pascal's triangle horizontally and diagonally. Thank you.